Next, we have this one. So again, we have to make use of substitution here. Notice here that I have a sine theta over d theta. And sine is the derivative of which function? That is the derivative of cosine, which appears here. So that will be our u. My u is cosine theta, and the derivative is negative sine theta d theta. Again, since this is a definite integral, I also have to change everything here in terms of u. So if x is equal to pi, then my u is cosine of pi, which is -1. If x is equal to 3 pi over 2, then my u is cosine of 3 pi over 2, which is equal to 0. So our integral now becomes pi to 3 pi over 2 becomes -1 to 0. And then my sine theta d theta is this one, negative du. So I have my negative here. And then I have my du over here. And then in the denominator, this is u squared plus 2u plus 2. So again, we have quadratic here and then no linear here. What is our strategy there? Whenever you have constant and then you have a square root of something and then a quadratic expression here, or a constant over a quadratic, you always make use of completing the square, because this one will result in an inverse trigonometric function. Let us complete the square. This is u squared plus 2u. But to complete this, I have plus 1. To make sure that they are the same, plus 1. This is also plus 1. And this one here is u plus 1 squared. And then plus 1. If we have integral of a squared plus w squared, what is this? This is tangent inverse of w over a times 1 over a. And then again, plus c. And therefore, this is negative. My a is 1. So this is negative tangent inverse of u plus 1 from -1 to 0. So this is negative tangent inverse of 1 plus, when u is -1, tangent inverse of 0. Tangent inverse of 1 is negative pi over 4, and then tangent inverse of 0 is just 0. So our final answer is negative pi over 4. Next, we have this function here, which involves an integral. Let us use the first fundamental theorem of calculus to determine f prime of x. Let us recall the first fundamental theorem of calculus. The first fundamental theorem of calculus states that if I have a function and this is the integral of something, so a raised to x, a is just a constant, and then I have f of t dt. Take note here that the variable here is not the same as x, okay? If we get the derivative of f prime of x, what we do is we just copy the integrand, but this time around, we input this variable here. This one, we put that. So this is f of x, okay? But what if this one here is no longer x, rather it is a function in terms of x, just like what we do here. So this is the first variation. The second variation is that if f of x is the integral from a constant to another function in terms of x, my derivative is equal to, we still copy this one, but this time around, we put this inside our function. So replace t by g of x, but do not forget to multiply it with the derivative of this expression over here. So going back to our problem, we now have that f prime of x is equal to, there should be a dt over here. We just copy this expression inside, but this time around, we put that inside our t. So this is square root of 1 plus ln of x plus 1. But don't forget to multiply it with the derivative of this expression, derivative of ln x plus 1. So for this one, it's okay to just leave it as the fourth power of ln x plus 1. And then the derivative of ln x plus 1 is 1 over x. That's it. That is our f prime of x. For our second problem, we want to find the equation of the tangent line to the graph of f at x equals 1. Since we are looking for the equation of the tangent line, what is it that we need? We need our point and we need our slope. Now, the point belongs in the graph of this one at x equals 1. So therefore, what is that point? That's the point 1, f of 1. And what is the slope? The slope is simply the derivative evaluated at x equals 1. Let us first compute for f of 1. My f of 1 is 1. I'll change x to 1, so that's ln of 1 plus 1. Take note, this is ln of 1. It's not ln of quantity 1 plus 1. ln of 1 is 0. So therefore, the upper and the lower limits are just the same. And therefore, there is actually no need for us to evaluate this integral since this entire thing is just equal to 0. Next, let us find f prime of 1. But in order to get f prime of 1, we need our f prime of x, which we already have earlier. So earlier, this is the value of f prime of x that we obtained, and therefore our f prime of 1 is just square root of 1 plus ln of 1 is 0. 1 raised to the fourth is still 1 over 1. So that is square root of 2. And therefore, the equation is equal to point slope form y minus the y coordinate f of 1. But our f of 1 is 0. This is equal to the slope, and our slope is square root of 2 times x minus the x coordinate, which is 1. This is the equation of your tangent line. Let us look at this word problem. So after ending their friendship, Al threw Vince's gift vertically from an elevation of 27 meters atop a building. So let us draw that. Let's say that this is your building. This is the ground. And Al is here, 27 meters from the ground. Unbeknownst to Al, Vin is at the foot of the building, here, and reaches out to catch the gift so he could return it to Al. If Vin's outstretched arms are 2 meters high, so his hands will be here, 2 meters, and the gift reached its maximum height after 2 seconds. Vin threw the gift vertically, and then after 2 seconds, here, so this one happened when t is equal to 2. So we want to know at what time will it hit Vin's hand. Okay? Alright, it says here that we have to use negative 10 meters per second squared for the acceleration due to gravity. Our a of t is negative 10. So our velocity is just the integral, which is negative 10 t plus a constant. Let's call that c. What do we want to do? We want to solve for this c over here. Now, how do we find our c here? It says here that the gift reached its maximum height after 2 seconds. This one over here. When you reach your maximum height, it means that the velocity there is equal to 0. When t equals 2, this means that your v there is equal to 0. So let me just write that. V of 2, this will be equal to 0. But our v of 2 will now be negative 20 plus c, which means that our c is equal to 20. So let me just write it. My v of t is negative 10t plus 20. And our s of t is equal to, integrate that. So we have negative 5t squared plus 20t plus another constant. But what will be this constant? This constant for our position function will just be the initial position, correct? Because when t is equal to 0, you will have your d. So again, let me just write it down. S of 0 is equal to 27. And when you substitute t equals 0, everything here will be 0 and you will be left with d. So we have S of t is negative 5t squared plus 20t plus 27. Our question is, when will Vin catch the gift? So if we go back to our problem, we want the value of t such that our s is equal to 2. So we want to find t such that s of t is equal to 2. Again, our s of t is negative 5t squared plus 20t plus 27. And we want this to be equal to 2. So we now have 0 equals negative 5t squared plus 25, dividing both sides by negative 5. This is just t squared minus 4t minus 5. So this factors as t minus 5 and then t plus 1. Therefore, we have t equals 5 or t equals negative 1. Of course, this is impossible. Our t cannot be a negative value, and therefore we just have a t equals 5. So we now say that after 5 seconds, Vin will catch the gift. For our last problem, we want to find the area, the perimeter, and the volume of a solid of this region. So what is the first thing that we need to do? We have to sketch the graph of the region. Let's start with x equals log 2y. I can write this as 2 to the x equals y, right? Those two expressions are equivalent. What is the graph of y equals 2 to the x? That is just this one, correct? And this is the point 0, 1. Next, y equals x minus 1 squared. That is a parabola with vertex at 1, 0. And you will have a y-intercept of when x equals 0, your y is equal to 1, right? And then we also have y is equal to 4. There's something here. That is just a horizontal line. This will now be the region. Okay, so first let us find the area of R using vertical rectangles. This is my rectangle. And then I want to slide this rectangle and see whether I always have the same upper bound and lower bound. So when I slide this rectangle over here, so when I draw it here, so it's still the same, right? Green and then blue here. However, when I am already here, I have a different boundary on my upper boundary is the red line and the lower boundary is the blue parabola. So therefore, it only means that I have to divide my region into two parts. And this is the first region and this is the second region. By the way, I will leave it up to you to get the points of intersection. These points of intersection will be 2, 4 and 3, 4. If we look at this rectangle over here, what is our length? The length is change in y. So we have to get what is the y here. What is our blue line? Y equals x minus 1 squared. And the green line is x equals log y base 2. However, what do we want? We want to get the y because what we want is this is the change in y. We have to solve for y in terms of x, but recall that that is y equals 2 to the x. Understand? So therefore, for region 1, the length is the higher value, which is the green one, 2 to the x minus the blue one, x minus 1 squared. And then we have the width. What is our width? The width of the rectangle is the x. By the way, I corrected the graph here because the vertex occurs here and this is at 2. So what will now be the limits of integration when we slide this rectangle for region 1? My x would be from x equals 0 up to 2. Next, for our region 2, I will draw my rectangle. So what will be the length here of this rectangle? Remember, we're getting the area of the rectangle, so it's just length times the width. The length here is again a change in y. So here, y here is equal to 3, and here my y is equal to x minus 1 squared. We have the higher value, 3, minus the lower value, x minus 1 squared. That's the length, and the width is again dx. And what is our x? If I slide this to cover the entire region, I can draw representative rectangles just so that you can see what I mean. So when we cover that, what is our x? X slides from 2 up to 3. So the problem only asks you to set up. There is no need to evaluate. Okay, next we want to find the perimeter of this region. So first, let us get the length of this one, the arc length. Let us first recall the arc length. What is our formula? If you have an arc of the form y equals f of x, x from a to b, the arc length is equal to the square root of 1 plus f prime of x, x from a to b. If you have an arc wherein it is in x is solved in terms of y, let's say u of y, and then y is an element of CD, the length is equal to the square root of 1 plus u prime of y, or dy, y from C to D. Now, which of these two formulas are we going to use when we want to get the length of this curve? X is in terms of y, so we will make use of this one, dx over dy, or that is in this case our u prime of y is 1 over y. I still have my ln2 here. So therefore, the length, let's call this L1. So L1 is the integral of 1 plus 1 over y ln2 squared, and then dy And then since this is y, in terms of y, what is our y here? For the green one, y runs from, what is this again? This is 1, and this is 4. Y changes from 1 to 4. And then for the red one, there is no need to use the arc length. This is just a horizontal line. And you have a change in x coordinates. So this one has a length of 1. And then lastly, for my L2, the blue one, that is for y equals x minus 1 squared. What are we going to use? This one or this one? Your y is in terms of x. So we're going to make use of this. So our dy over dx is 2 times x minus 1. And therefore, our L2 is equal to the integral of 1 plus 4 x minus 1 squared. That is the square of this times dx. And then my x runs from what for the blue one? From here up to here. So that is from x equals 0 until 3. So therefore, our final answer is L1 plus L2 plus 1. Lastly, we want to find the volume of the solid generated when R is revolved about the line x equals 3. This is the line x equals 3. So this is the axis of revolution. Okay, since our axis of revolution is a vertical line, we will make rectangles which are perpendicular to it. So we will make use of horizontal rectangles. Now take note that here, my right limit is the blue line and then here it's the green line. However, when I slide my rectangle in my region, when I reach up to here, it will now start to change. Correct? So that means that I need to divide it into 2 parts. I will first generate the solid when you revolve this one along the line x equals 3 and then for this one. Since our axis of revolution is not part of the region, it only means that we will have a washer. There will be a hole when we revolve this, just so that you can see. This part over here is the hole. This one over here. What is it that we need to remember for washers? The volume is equal to pi times outer radius squared minus inner radius squared times the height or the thickness of your slab. What will be the outer radius here? The outer radius, remember, you have to start from the axis of revolution and then the bigger one. So from here to here. This yellow line, that's the outer radius. But the outer radius, that is a change in x, correct? What is our x here? My x here is 3. What is the x here? This is the green line, so x is equal to log y base 2. So the outer radius is this, the bigger one, minus the smaller one. So it's 3 minus log y base 2. What about the inner radius? The inner radius, again, you start from the axis of revolution from here up to here, right? That's the inner radius. So again, on this part, our x is equal to 3. On this point, this is for the parabola. The parabola y equals x minus 1 squared. But what we need is the x here because we want to get the change in x. So when we solve for x, I have plus or minus square root of y equals x minus 1. And so x is equal to 1 plus or minus square root of y. But which one is x here? on this part over here, it's greater than 1, correct? So for this part over here, your x is 1 plus square root of y. For this part over here, your x is 1 minus square root of y. But what do we need only for the inner? It's this red one. So it's 3. The x here is 3 minus the inner one. The x is 1 plus square root of y. So let's call that for solid 1, S1. So it's pi integral of outer squared minus inner squared, this one. And then what is the height? The height of the slab is change in y, which is dy, which is correct. For S2, this is for this part over here. The outer radius is from here, the bigger one, from here up to here. Okay? So it's 3 minus, so 3 minus this. This is for the blue parabola, and that is the x there. Remember, again, this is a horizontal rectangle, so the length is the change of x. The x here is equal to 3. The x here is 1 minus square root of y. So 3 minus 1 minus square root of y. For the inner, so we're starting from here. So that is 3 minus, what is the x here? The x here is 1 plus square root of y. And therefore, for our S2, it's equal to pi times the outer is 3 minus 1 minus square root of y squared minus 3 minus, and then I also have dy. By the way, I forgot the limits of integration for S1 going back. There, when we slide this rectangle over here, where do we start? This is 1 up to 4. And what about for S2? Our y changes when we slide this rectangle. Our y rises from 0 up to 1. And therefore, the solid is just this one, S1 plus S2. That's the volume of the solid.